Welcome to qnawire.
Here we're going to have two cars. One car is moving at a velocity of one car has a mass of 1.6 times 10 to the 3 kilograms. This is going to be our first mass, and it's traveling at a velocity equal to 40 kilometers per hour on the west direction. That means that we're going on the negative x-axis, so we're going to multiply the velocity with the negative I unit vector. A second car, with a mass equal to 1.4 times 10 to the 3 kilograms, is traveling at a velocity equal to 45 kilometers per hour in the north direction. That means that this guy is going on the positive y-axis, so it corresponds at j unit vector. Notice that the velocities of each of the cars is going to be located on only one dimension, but they are going to collide in an inelastic collision, and we want to know what is the final velocity after the collision occurred. In this case, since the problem starts with two objects that are moving on one dimension and then they collide, what is going to happen is that the final velocity is going to be on two dimensions. So we're going to have a final velocity on x and a final velocity on y. So the magnitude of the velocity is going to be equal to the square root of the final velocity on x squared plus the final velocity on y squared. So in order to calculate both of these velocities, what we're going to do is apply the equation corresponding to the conservation of momentum. We're going to have mass 1, velocity of 1 initial, plus mass 2, velocity of 2 initial, and this is going to be equal to the sum of the masses, because they're going to get stuck together after the collision, times a final velocity that is going to be in common. So, in both cases, this equation can be applied to the x and to the y-axis. So in the x-axis, this is going to be equal to mass 1, velocity 1 on x, plus mass 2, velocity 2 on the x-axis, divided by mass 1 plus mass 2. In this case, as you can see, the second car is going to have no x component. That means that this factor is going to be equal to 0. So this equation becomes that the final velocity on x is going to be equal to mass 1, which was 1.6 times 10 to the 3 kilograms, multiplied by the velocity of that car, that is going to be 40 kilometers per hour. In this case, we can put the minus sign over here because we know that the velocity is going to be on the negative x-axis, divided by the sum of the masses. In this case, the sum is going to be 1.6 plus 1.4. It is going to give us 3 times 10 to the 3 kilograms as the sum of both of them. So the final velocity on x is equal to negative 21.333 periodic kilometers per hour in the x-axis, so in the I direction. Now, for the final velocity on y, we're going to apply the same reasoning. Mass 1 v1 on y plus m2 v2 on y divided by mass 1 plus m2. And now the velocity of the first car and the y component is equal to 0, as you can see here. This is going to give us now the mass of the second car, that was equal to 1.4 times 10 to the 3 kilograms, multiplied by the velocity of the second car, which is 45 kilometers per hour. In this case, it is on the positive y-axis, so we don't need to add any sign, divided by 3 times 10 to the 3 kilograms. So we end up with 21 kilometers per hour on the y-axis. With this information, we know that the component of the velocity is going to be a vector on the xy axis, where we have north, south, east, and west, that is going to be on this direction. This is going to be our velocity vector. On the y position, is going to have 21 kilometers per hour. And on the x position, it's going to have 21.333 kilometers per hour, corresponding to the components of velocity. Okay, so with this, we can proceed with the final velocity, which is going to be the square root of final velocity of x plus final velocity on y, both of them squared. And this is going to give us 21 squared plus 21.33333 squared, taking the square root of both, 29.35 kilometers per hour. 29.935 kilometers per hour. Of course, this is going to be the magnitude of the final velocity, meaning the final speed of both of the cars. You can also write down the velocity vector directly as 21.333 with a negative sign on the I direction plus 21 on the J direction. And all of this in kilometers per hour. Or you can also say that the velocity vector is going to have a magnitude of 29.935 kilometers per hour, and we want to know the angle. The angle is going to be north of west, and we can find the angle easily by taking either sine, cosine, or hypotenuse. In this case, let's use this as reference. Let's use sine of theta, which would be equal to 21 divided by the hypotenuse, that is 29.935. So theta would be arc sine of 21 over 29.935, which gives us a value of theta of 44.55 degrees. So this is another way to write down. That is going to be the velocity, 44.55 degrees north of west. Let me make this force a little bit more. Let's put it direct. 44.55 degrees north of west. So those are the possible ways to write down the answer directly. So with that, it would be all. Thank you very much and have a good one.